All right, make sure you have your notes over scale factor, and let's get started. At the end of this lesson, you should be able to calculate scale factor to test similarity. All right, so what is a scale factor? So the ratio that you get when you divide corresponding side lengths of similar figures is called the scale factor. When we were learning about similar figures, we noticed that the ratio of the corresponding side lengths are all equal because the ratio is all simplified to 3/4, as you see here. That is what we did at the end of our last video. So we could say that the scale factor of triangle LMN to triangle, so LMN to triangle QRS is 3/4. So the ratio of the corresponding sides reduced to the same number. That's your scale factor. Another way to describe a scale factor is that it's a multiplier. So what are we going to multiply our first figure by to get to our second figure? So in this example, the scale factor of triangle ABC to DEF is 2. That means that the second triangle is 2 times as big as the first one. If you multiply a side from here, so let's do AC is 6. So if we do 6 times 2, we get 12. And DF corresponds with AC, and it's 12, so that's correct. They correspond, multiply the first one by our scale factor, which we said is 2, you get the corresponding side length. So you can also get 2 as the scale factor by finding the ratios. So you do the second one first, so we'll do DF to AC, so that's 12 over 6. So 12 divided by 6 is 2. We can also check our other corresponding side lengths. So we got BC and EF. Remember, the second one will go on top. So it's 18. BC is 9. 18 divided by 9 is 2. And let's check the last one. So then we have, for DE, we have 16, and AB is 8. 16 divided by 8 is 2. So all of these we got 2, so that means our scale factor is 2. So here's another example. You can find the scale factor for the rectangles above by finding the ratio between the shapes. So let's do LO and SV. So SV is 15, LO is 5. 15 over 5, that simplifies to 3. So then let's check one more to make sure. Let's do ON and BU. So we got 6 over 2, which simplifies to 3. So that means our ratio is 3, our scale factor is 3. If you can't figure it out, you would just divide if you can't find the ratio. So the scale factor is 3 because we multiply each side by 3 to get from rectangle LONM to get to rectangle SVUT. So does the order matter? Well, I've already told you order matters on this stuff. So yes, it does. The order is very important when you write a scale factor. If the scale factor from our first rectangle to our second rectangle, let's figure out what it is real quick. So we have AB to WX. So then that'd be 20 over 5. So that would simplify to 4. So if we say our scale factor is 4, that means the second shape is 4 times larger. So we would have to multiply it by 4 on each side. So if we switch the orders and we did 5 over 20, that would be 1/4. So if we multiply 5 by 1/4, will we get 20? No, our shape would be smaller. So you have to make sure you do the correct order. So what happens if we switch the order? In this case, we wouldn't want to say the scale factor is 4 because the second shape is smaller. So we have to remember the scale factor is a multiplier. So what can we multiply by if the second shape is smaller? So if we know the scale factor when the second shape is bigger, in this case, we knew to go from this shape to here, it was multiplying by 4. But now we're going the other way, and we're still multiplying here. So you can't just say, oh, we're going to divide by 4, because remember, multiplier is scale factor. You multiply. So what do we multiply by? So if we know the scale factor to go from small to large was 4, we can do the reciprocal. So you can write the scale factor as the reciprocal, just flip it upside down. So if we flip 4, remember it's basically 4 over 1, we flip it, it would become 1/4. So we would multiply each side by 1/4 to get to the smaller shape, the smaller figure. This happens because the ratios will all be switched around. So when we did our first one, on that last slide, we did 20 over 5 because we were trying to get to 20 from 5 and we got 4. But now we're going the other way. So we do the second shape on top, which would now be 5 because we're going to 5. And it started 20, so it becomes 1/4. So in the example above, we did 20 over 5, and then we also can do 16 over 4 is what we originally did. And to get the scale factor when the second shape is smaller, you just flip it. So if you're going larger, it's going to be a whole number. It's going to be larger than 1. If you're going smaller, it's going to be less than 1. So pay close attention to the order of the two shapes. So the first shape listed is what you start with. So normally you would start here. So it's saying we're going from triangle 1 to triangle 2. It is larger. So our scale factor is going to have to be larger than 1. But now if we're getting smaller, the second shape is smaller. In this case, it's saying we're going from triangle 2 to triangle 1. Normally in the picture, it would be flipped around, but in this case, it's not. But since we're going smaller, our scale factor is going to be smaller than 1. And we normally leave it as a fraction, so do not change these to decimals, okay? So we're going to assume all the shapes in these examples are similar and pay close attention to the order of the shapes when finding our scale factor. So we want to find the scale factor of trapezoid EFGH to trapezoid JKLM. So we need to see what we can multiply by. If we can't figure that out, then we'll have to set up a ratio. So I'm going to start with EF, and I see it corresponds with JK. So to go from 5 to 10, I multiply by 2. So that means my scale factor is 2. I can also double check because if I do 7 to 14 times 2, 7 times 2 to 14, correct, and 8 times 2 is 16. So our scale factor is 2 here. All right, so now this one, it wants us to find the scale factor of triangle PQR to triangle STU. So same thing, we're going larger. So we know we're going to multiply by a number greater than 1. Off the top of my head, I can't think of what I can multiply 10 by to get to 15. So that means I had to set up a ratio. So remember, you do your second shape on figure on top. So 15 to 10, and I'm just going to set all of these up just so we can make sure we did it correct. And then 12 and 8. So I can divide both of these by 5 on this one. And so then you get 3 over 2. This one I can divide by 3. 3 over 2. And this one I can divide by 4 on top and bottom. So you get 3 over 2. So our scale factor to go from PQR to STU is 3/2, or 3 over 2. So now on this one, it wants us to find the scale factor of triangle STU. So we're going to start here to triangle PQR. So we are going smaller. So that means our number has to be less than 1. So once again, I don't know what I can multiply 15 by to get to 10. So I'm going to set up a ratio. So I'm going to put the second shape on top. So 10 over 15. And I'm going to do it for all of them. So then 6 over 9, 8 over 12. And now we need to simplify our ratios. So I can divide by 5 on this one. So that'd be 2 over 3. I can divide by 3. So that'd be 2 over 3. And I can divide by 4 on this one. So 2 over 3. So if you notice, the only difference on example 3 from example 2 was the fact that we went from larger to smaller this time. So that means our number had to be less than 1, which we got 2/3, which is less than 1. It is also just the reciprocal of our example 2, because we got 3 halves when we went from PQR to STU. Now we're going from STU to PQR, so it just flipped, and we got 2/3. All right, so now you are going to practice and do your assessment on boom cards. You must earn 16 diamonds in order to move on.